The James Webb Space Telescope set off on a journey to the deepest parts of our solar system, a mission that had never been done before. It traveled to places on Pluto that no other spacecraft had reached, which was a significant milestone. The pictures sent back by the telescope were breathtaking, showing Pluto in ways never seen before. It revealed Pluto's tallest mountains, beautiful slopes, old craters, and the famously cold and icy heart, which scientists still do not fully understand. Why does NASA want to examine Pluto again with the James Webb Space Telescope? And how does the current study of Pluto help pave the way for future missions to the farthest reaches of our solar system? Every new idea and piece of modern technology adds a new chapter to the story of our space exploration adventures. Looking back, it's clear that space projects have come a long way since Neil Armstrong walked on the moon. However, the vastness of the universe and the fact that many of its mysteries remain unsolved remind us of how much more we need to learn. This is where NASA's new projects and tools, like the James Webb Space Telescope, come into play. The James Webb Space Telescope was launched to explore the beginning of the universe and to learn about distant planets. Most importantly, the telescope represents a massive leap forward from previous NASA efforts. It's an epic journey to uncover the mysteries of the past in the universe. While we're still interested in the Big Bang and how our solar system formed, our primary interest lies in answering the critical question: is there life on planets other than Earth? Could what we learn about our solar system lead to a new field of study? Will the new insights we gather from the James Webb Space Telescope force us to rethink what we know about the universe? These questions challenge us to reconsider our understanding, particularly in regard to Pluto and why we once called it a small planet. Thanks to the New Horizons mission, we now know much more about Pluto. This billion-dollar investment has significantly altered NASA's approach and enhanced our understanding of this icy world. Before the New Horizons mission, our knowledge of Pluto's surface was limited. The Hubble Space Telescope had provided the clearest image of Pluto's surface in 2002, revealing a strange mix of colors, orange, white, and black, along with a bright spot that piqued scientists' interest. Studying Pluto at that time was like attempting to solve a puzzle with only a few scattered pieces, as the Hubble could only provide limited details. The arrival of the James Webb Space Telescope, however, changed the game. It went into orbit around Pluto and sent back stunning images, allowing scientists to learn much more about the distant world. It was akin to getting a backstage pass to a magic show, revealing the hidden wonders of Pluto. These images astonished scientists and captured the attention of people worldwide, sparking widespread interest and enthusiasm about the unknown regions beyond our solar system. The main goal of the New Horizons mission was achieved in July 2015, when the spacecraft flew past Pluto and its moons, sending back the first detailed pictures of this faraway object. The success of this mission marked a major step in the search for life in space. Astronomers learned new things about Pluto and its moons that had previously been unknown. The mission's success also gave NASA more ways to study the vast Kuiper Belt, an area that needed further exploration to better understand distant celestial bodies. NASA's primary goal was to find planets between Neptune's orbit and about 50 astronomical units, AU, from the Sun. The closest flyby with Pluto and its largest moon, Charon, was undoubtedly the most fascinating part of the journey. New Horizons also captured clear images of Pluto's 4 other moons: Nix, Hydra, Kerberos, and Styx. It took 15 months to gather all the data, but by October 25, 2016, the goal had been achieved. The spacecraft collected 6.25 gigabytes of valuable data, which proved to be crucial for NASA's study of the dwarf planet. The massive amount of data collected from the New Horizons mission was vital for NASA's study of Pluto. The findings were so different from what experts had expected that new high-tech data models had to be developed to make sense of the results. Over time, it became clear that Pluto's surface and atmosphere were more dynamic than previously thought, even after its reclassification as a dwarf planet. Pluto proved to be a more active and changing world than scientists initially believed, prompting NASA to reassess its understanding of this distant object. One of the most striking features of Pluto is its heart-shaped region, known as the Tombaugh Regio. This geological feature, named Sputnik Planitia, plays a major role in shaping many of Pluto's surface characteristics. Despite its name, the heart is not warm and beating. Rather, it is cold, icy, and nearly frozen. This vast area is made up of nitrogen ice, covering more than 1 million square miles. The fact that this giant nitrogen iceberg lies at the center of Pluto is important, as it causes a phenomenon called true polar wander, which shifts the planet's spin axis. Scientists were surprised to find that Pluto's heart-shaped basin is adjacent to its largest moon, Charon, a discovery that has important implications for understanding the relationship between the two bodies. Pluto's tilt and the effects of its gravity on Charon reveal important aspects of its dynamic nature. The alignment of Pluto's heart with Charon's tidal axis shows that the heart has a significant effect on the planet's orientation, meaning that Pluto has tipped slightly on its axis due to the gravitational pull between the two bodies. This new information helps us understand why Pluto is such an intriguing and constantly changing world. Although humans cannot live on Pluto, its icy surface and the massive nitrogen ice at its core give it unique features. For instance, Pluto's tilt is caused by its imbalanced mass, and its gravitational relationship with its moons results in true polar wander. Despite advances in technology, scientists still don't know the exact chemical makeup of Pluto's underground ocean, so they can't yet determine if it could support life. Nevertheless, NASA's continued investment in exploring icy planets like Pluto remains crucial. Even if life on Pluto is unlikely, its study helps scientists learn more about planetary science, from its geological features to its formation and ongoing changes. Recent advances in technology have also led to exciting discoveries about Pluto. For instance, scientists have found evidence of a hidden ocean beneath Pluto's icy surface. This groundbreaking discovery challenges our previous understanding of the planet's structure and history, suggesting that Pluto may share similarities with other moons like Titan, Enceladus, and Europa, which are known to harbor subsurface oceans. Although there is no evidence to suggest that life currently exists in Pluto's ocean, the possibility raises important questions about whether life could exist in the oceans of other planets. In addition to this discovery, NASA's Cassini mission found an ocean rich in phosphorus beneath the cold surface of Enceladus, a moon of Saturn. Since phosphorus is a key ingredient for DNA and RNA, the building blocks of life, this discovery has sparked endless debates about the potential for life elsewhere in the universe. While Enceladus remains a promising target for astrobiological study, determining whether Pluto is habitable is much more challenging. The advanced imaging equipment we now have allows us to capture clear images of Pluto's surface, but we still lack the technology to test whether it could support life. Pluto remains a fascinating subject of study. While we do not yet know what the future holds for the exploration of this faraway world, its icy surface and mysterious properties continue to surprise scientists. From the discovery of liquid nitrogen rivers to the potential existence of an underground ocean, each new finding brings us closer to unraveling the many mysteries of this small but dynamic planet. The pictures sent back by the James Webb Space Telescope are another significant step forward in our understanding of Pluto and other distant celestial bodies. With every new discovery, we move a little closer to understanding the complexity of planets like Pluto, and with that, we inch ever closer to answering the fundamental question of whether life exists beyond Earth. As we continue to push the boundaries of what we know, the journey into the depths of space will undoubtedly be both exciting and educational. As we venture deeper into understanding Pluto and its surrounding environment, the significance of the New Horizons mission and the James Webb Space Telescope becomes ever more apparent. Both missions are helping scientists piece together a more complete picture of this distant world and how it relates to the larger context of our solar system and beyond. Every discovery made by these spacecraft not only provides new information about Pluto, but also opens the door to understanding other celestial bodies that share similar characteristics. One of the most intriguing aspects of Pluto is its complex atmospheric behavior. Despite being so far from the Sun, Pluto still maintains a thin atmosphere composed primarily of nitrogen, with small amounts of methane and carbon monoxide. This atmosphere is constantly undergoing changes due to the planet's orbit, which takes it farther from the Sun over the course of its 248-year journey around the star. As Pluto moves away from the Sun, its atmosphere cools and freezes, causing the gases to condense and fall to the surface as snow. Scientists have observed that these layers of frozen nitrogen and methane accumulate in certain areas of the surface, giving Pluto its unique, icy appearance. Interestingly, Pluto's atmosphere does not behave the same way Earth's does. On Earth, the atmosphere is thick and stable, with a consistent mix of gases that support life. However, Pluto's atmosphere is much thinner and behaves in a more dynamic way. The gases are constantly shifting, and the freezing and thawing cycles lead to the formation of hazes and clouds that drift across the surface. These hazes are made of complex organic molecules that are formed when ultraviolet light from the sun interacts with the atmospheric gases. The result is a kind of smog that can obscure Pluto's surface and contribute to its mysterious, hazy appearance. Pluto's atmosphere is also extremely sensitive to its position relative to the sun. As it moves closer to the sun, the increased heat causes some of the ice to vaporize and replenish the atmosphere, leading to temporary atmospheric expansion. However, when Pluto moves away from the sun, the atmosphere begins to collapse and freeze. This cyclical change in atmosphere has been observed and studied by NASA's missions, providing valuable insight into how planetary atmospheres can behave differently in extreme environments. Pluto's atmosphere may hold key clues to understanding how other faraway planets and moons in our solar system interact with their surroundings, particularly those that exist in the outer reaches, such as those orbiting distant stars or exoplanets. Another fascinating aspect of Pluto's environment is the interaction between its surface and its moons. While Pluto itself is a relatively small object in the vastness of space, it is not alone. It is part of a complex system of moons that includes Charon, the largest of its 5 known moons, as well as Nix, Hydra, Kerberos, and Styx. These moons have been a subject of intense study because of the way they interact with Pluto. Charon, in particular, has a gravitational relationship with Pluto that causes the two bodies to lock in what is called a synchronous orbit. This means that Pluto and Charon always show the same face to each other, much like the Moon does with Earth. This gravitational interaction has significant effects on the dynamics of the entire system. Charon's influence on Pluto is most evident in the planet's orientation. The gravitational pull between Pluto and Charon causes what is known as tidal locking, where the two bodies exert a force on each other that can cause the surface of Pluto to shift. This shifting, known as tidal flexing, may be responsible for some of the planet's geological features, such as the heart-shaped area on its surface. Scientists have theorized that tidal flexing could cause internal heating within Pluto, which might be responsible for some of the geological activity observed on its surface, such as cryovolcanism. In addition to its moons, Pluto's interaction with the solar wind also plays a role in shaping its surface and atmosphere. The solar wind is a stream of charged particles emitted by the sun, and it can have a significant impact on planets and moons that are far from the sun, like Pluto. These particles can strip away the upper layers of a planet's atmosphere, and for Pluto, this process could have been responsible for some of the atmospheric changes observed over time. As Pluto's orbit takes it farther from the sun, the planet is exposed to less solar wind, which may explain why its atmosphere is so thin. One of the most important missions dedicated to understanding Pluto's environment was the New Horizons flyby in 2015. This historic event allowed scientists to gather an unprecedented amount of data on Pluto's surface, atmosphere, and moons. The spacecraft passed within 7,800 miles of Pluto, capturing detailed images and measurements that would otherwise have been impossible to obtain. The images sent back by New Horizons revealed a wealth of new information about Pluto's diverse surface features, from icy plains to towering mountain ranges. One of the most surprising discoveries was the presence of what appeared to be vast, flowing glaciers made of nitrogen ice, which could suggest the presence of a subsurface ocean, similar to what has been observed on other icy moons like Enceladus and Europa. The New Horizons mission also provided valuable data on the surface composition of Pluto, revealing that its surface is a mixture of ice, rock, and other compounds. This has led scientists to conclude that Pluto is not just a cold, inert object in space, but rather a dynamic and evolving world with a complex geological history. The planet's surface is covered in vast plains of nitrogen ice, which are constantly shifting and changing over time. The presence of large, tall mountains, some of which rise up to 11,000 feet, also suggests that Pluto has experienced significant geological activity in the past. The fact that these mountains are made of water ice which is much softer than rock, further supports the idea that Pluto has undergone significant tectonic activity. The icy terrain of Pluto has raised many questions about the processes that drive its geological activity. Some scientists believe that the planet's internal heat may be sufficient to cause cryovolcanism, or the eruption of icy materials from beneath the surface. The presence of large, flat plains that seem to have been resurfaced relatively recently also suggests that Pluto may have experienced a form of tectonic activity in the past. Cryovolcanism has been observed on other icy moons, such as Enceladus and Europa, and it could be a key process in shaping the surfaces of other distant planets and moons. Another remarkable feature of Pluto is the existence of vast dune fields, which are similar to the dunes found in desert regions on Earth. These dunes are made of methane ice particles that have been blown by winds across Pluto's surface. The dunes are particularly striking because they are much larger than those on Earth, with some of them reaching heights of several hundred meters. The presence of dunes on Pluto suggests that the planet has a dynamic atmosphere, capable of producing winds strong enough to move ice particles across its surface. These findings raise important questions about the role that wind and weather play in shaping the surfaces of distant planets and moons. As technology continues to advance, scientists are gaining new insights into the mysteries of Pluto and other distant objects in the Kuiper Belt. The continued study of Pluto is crucial for understanding the broader processes that shape the outer reaches of our solar system. Pluto, once considered a mere curiosity, is now emerging as a complex and fascinating world with a dynamic surface, atmosphere, and potential for subsurface oceans. The discoveries made by New Horizons and the James Webb Space Telescope are just the beginning of what promises to be an exciting era of exploration in the outer solar system. These missions are providing us with the tools to unlock the secrets of this faraway world and to better understand the forces that govern the universe.